Okay, so today we're going to talk about ways of transferring rotational motion and some of the advantages and disadvantages of those methods. So, rotational force or torque can be transferred via different methods, and this is not an extensive list. For example, a very common way of transferring rotational force will be through a drive shaft. And it's not even on here. But the ones we're going to talk about today are the belt, chain, and gears. And these methods are somewhat unique in that they are able to change the torque and the rotational velocity, the angular velocity, um, from their input to their output. And that can have an advantage. For example, an engine on your car has a certain RPM that it can work at. Somewhere between maybe 700 RPM and 6,000 RPM. Your wheel needs to rotate, may need to rotate as slow as 1 RPM. So you can do that, but you need a way of slowing down that rotational speed, and you can do that via a transmission, and the transmission uses usually gears. These are useful to us in more ways than one. So not only to get rotational motion from one point to another, but also to change torque and RPM. So belts. There are two types of belts. There's timing belts and there's V belts. What you see here is a timing belt. So a timing belt, as you notice, has this tooth profile here. Okay, so there's a tooth profile, and therefore it has a pitch. So a V belt is a little different. V belt is actually not quite that much of a V. It actually makes a pattern, something like that. A V belt can be used, for example, on your pulley system for the fan in the front of your car. May use a V belt. V belts are used in lots of industrial applications where you need motion transfer, but it's not necessarily high torque or necessarily needing to have a 1-to-1 ratio. In other words, if the belt slips of some sort, if the belt were to slip, it wouldn't be an issue. Anyway, a belt requires no lubrication. It's usually low maintenance. The belt can actually absorb shocks because it typically has some amount of stretch to it, and usually there's a tensioner and it has to be installed, and that tensioner can actually help absorb some shocks as well. They're very quiet. That is a huge advantage, especially in some places where you need to, your noise level is already high. You don't want to increase it, so it may be useful to use a belt just to keep your noise down. Smooth. What does that mean? Does that mean that it's actually smooth when you touch it? No, it means that usually there's not any jerkiness or sudden acceleration. There's very little backlash, so it's quite. When you engage your rotation from your drive gear, your driven gears engage quite nicely. So they tend to accelerate and don't put sudden jerks. In other words, pulleys are generally less expensive and they wear over a longer period of time. So there is disadvantages. One is that belts typically can wear, or not wear, but will degrade over time, and especially if they're not being used. If you ever hear your belt on a car squeal, that's an example of a belt that's not been tensioned properly, so they have to be tensioned. If you ever look at belts, you can sometimes see that they will dry rot. Okay, so that's over time. They the rubber or the materials they're made out of don't will degrade. Um, and again, just in general, more susceptible to being damaged by the environment. A chain has no slippage. That's an advantage over a V belt. Timing belt, of course, it's not likely to slip, but a chain is even less likely to slip than a timing belt is. Have a very long life as long as they're lubricated. Um, Chains are extremely durable. And they can operate in very hostile environments. So, for example, like a chainsaw uses a chain with teeth on it. I would say that would be a fairly hostile environment compared to anything else that you would have. And they have a fairly long shelf life. So whereas belts and gears have a long shelf life as well, but belts have a definite shelf life. So if you have a lot of belts stored up, if you go, to pick one out and it's been sitting on the shelf for 10 years, it may not be good. In fact, most likely it's not good. They are noisier. They can elongate due to wear of the teeth in the chain. Sprockets may need to be replaced whenever the chain gets replaced, whereas pulleys usually don't have to be replaced at all. And there's generally backlash. So if you notice down here on the bottom side, if the wheel is rotating in this way, first of all, let me start with this. The wheel rotates in this direction, then the chain is being pulled this way, which means that this bottom part right here is sort of can sag. Okay, typically will sag a little bit. So if there's tension or there's looseness inside of the chain in the forward direction, it'll be on the bottom side. But if the wheel is going in the opposite direction, so in other words, if it's going in this direction, then now your tension is on the bottom, which means that the top will sag. Okay? So the difference is whenever this rotates, this pinion up here, whenever it rotates in one direction and then reverses to rotate in the other direction, there's a small amount that it may rotate just to tension the chain on the opposite side, and that's what we call backlash, and we'll talk about that more in a second. So gears, the biggest advantage to gears is they can handle extremely high torques and very high speeds. Okay, this is something that just chains and belts just cannot handle. There is no slippage between them. They can change torque and velocity from one value to another in a very compact space. So that's like a planetary gearbox can change their value, the torque and velocity very quickly in a very small space. A transmission is an example of that as well. Long life expectancy, high efficiency, high power to weight ratio. Now this right here has a caveat. Only in high power applications. So only in high power applications. In low power applications, chains and belts can be competitive. But in general, in high power applications, there is nothing else you can go to anyway. And a belt, in order for a belt to work, you'd have to have many belts or a very, very wide belt. And even then, you still have issues because you have to have some way of tensioning it. So disadvantages of them are transferring rotational motions over long distances impractical, just because belt or chain or gears have to be side by side. So You can use idler gears to get from one place to another, but it's just not very practical. There can be backlash in gears, although in general it'll be less. Um, although it's somewhere between a chain and a belt. A belt generally has no backlash, assuming it's tensioned properly. Chains typically almost always have backlash. Gears are somewhere in between. Can be very expensive. That's a big one. So gears are typically made out of tool steel, or it can be aluminum. Lots of materials that they can be made out of that are typically not cheap, and just generally just pretty expensive. And of course they require lubrication. So and they have to be constant lubrication in a lot of applications, especially high power applications. In that case, you need to have a gearbox and some sort of fluid for the gears to be well lubricated. Alright, so here's a couple of statistics I'm giving you. I can give you for comparison of chains, belts, and gears. So typical Spur gear has a transmission ratio optimum between 2 and 8. It can be up to 20, and it has a very high efficiency. Notice 97 to 99%. Power to weight ratio can be upwards of 1.8 to 0.4 kilograms per kilowatt. Chain, tooth belt. So notice these are all going to be lower ratios. So this is a lower ratio. So flat belt can actually get on up there again, but in general, your belt or your gears are going to have a higher gear ratio that they can achieve. The efficiencies of your gears are also going to be higher, but all these others are fairly close. Okay. Power to weight ratio, gear is the best. Flat belt, actually a tooth belt would be the next best, followed by a flat belt, and your worst is going to be your chain, which will be as expected. Probably as far as pricing goes, a flat belt and chain are going to be pretty close to the same. Tooth belt's going to be next. So as far as pricing, we'll say these two are number 1. This would be 2. This would be 3 as far as pricing goes. So this is for pricing. All right, backlash. As I said, that backlash is a what happens whenever your driven gear does not engage directly when you engage your drive gear. And this could be a problem for high accuracy applications like CNCs, where you have rotational motion being converted into linear motion. That linear motion needs to be at exact locations, and if it's not, then you're not creating a correct part. And so when gears, if you mesh them exactly correctly, then you're going to have too much friction. So there has to be some backlash in gears. Belts have the advantage of having very little backlash to almost no backlash, just because they have a tensioner. And then, of course, chains always have backlash. Things to look out for: if you don't have lubrication in gears, you get that. Chains can seize if they don't have lubrication. Notice that the chain kind of goes down and up. It's wavy. It's not supposed to be like that. And then belts can dry rot. That's a V belt that's been dry rotted. You may see that on a car or something. Lots of other things that can happen, but these are very common things to see. So for chain and belt, here's your V belt, of course. This is a V belt. This is a timing belt or tooth belt. So for sprockets on for a chain, you've got, these are all sprockets. Notice the different profiles. For gears, there's lots of different kinds of gears. So you have planetary gears, worm gears. Worm gears are like in a seat motor or something of that nature. Rack and pinion converts linear motion into, or sorry, rotational motion into linear motion. By the way, the planetary gears are very, very good for compact transmission of changing gear ratios in very compact applications. Helical gears, or what you're going to find it in transmission. Straight spur gears are very common. You see them in lots of applications, but again, not going to find them in a transmission. Helical gears, not going to find those as often. And then you have plain bevel. You won't see those a whole lot. Spiral bevel converts motion on a 90-degree axis. And that's about it. Alright, so your belt, or anything that is timed or has a, it's like a timing belt, or a chain, or a gear, are all going to have pitches, okay? And basically that's just a relationship between the diameter and the number of teeth, or in the case of a chain or a belt, the linear distance between teeth, okay? So you can have a pitch of 10, let's say 2 millimeters. So a 2 millimeter pitch might be a, 2 millimeter pitch. You can also have the same thing here, 2 millimeter pitch. For here, you've got, if you take the distance, you lay it around, you can also have another pitch there, okay? Same thing here. This is just distance. Whenever you are getting gears or belts or chains, you must match up the pitch of the belt to the pitch of the pulley, pitch of a chain to pitch of a sprocket, or the pitch of two gears together. In the case of gears, you also have to have the right kind of gears, so you can't put a helical gear with a spur gear. Okay, so this is an example of a spur gear we've seen on the last slide. Can't put a helical gear and a spur gear together. V-belts don't have a pitch. There is no pitch for V-belts, although they do have widths. They don't have pitch. So on a gears also have width. Belts have width, and chains typically don't have a width. They have a size numbering, but they don't have a width. And they also, of course, have pitch, like anything else. Alright, so that's all I've got. If you have any questions, let me know.